Just have to go
Okay.
get the webcam because like the camera isn't working, so I just have to go get the webcam.
Go get the webcam. You're going to go now, or you mean later sometime? So today's class you'll be with the camera off. Is that what you're saying?
No, I'll go now.
Okay, you could have gone a few minutes ago, right? All right, come back soon. But meanwhile, we'll just get started. Recording is on. Let me just share screen. Okay, and then I'll open up this homework. Homework 3. Okay, we did till question 4. And we were going to do that 11-digit number A1234. Yeah, that's a good question. I want to spend some time on it. So let's finish the rest of those questions, and then we'll come back to this question 5 at the end. So let's continue with question 6. We'll come back to.
Sir, which question 5?
We have not discussed question 5, but we'll go with question 6 right now in homework 3. Are you able to see my screen?
So can I answer this one?
Okay, hold on 1 second. So all of you on the same page with me? So we are skipping question 5 for now. Towards the end of the class, we'll discuss question 5. Question 6. Yeah, you guys don't have to ask who will answer, but since you opened it up, yes, go ahead, please. Harsh, yeah.
Yeah, so sir, I ignored the 2000. It was just an extra intrusion.
Yeah.
And then I multiplied 23 by 3 because they choose 3. So it's like x divided by 3 is equal to 23. So I
Exactly.
multiplied it by 3. So I had to get the sum as 69. So then 69 was very easy to get, like by adding 2003, 2027, and 2039. And then then the remaining numbers were 2011, 2017, and 2029.
Yeah, and then therefore the average worked out to be. What is the mean of the remaining numbers? Therefore, Harsh. Hello.
Hello.
Oh, you froze for a second. Okay, yes, I heard you all till the end. So therefore, what is your final answer? What is the mean?
2019.
2019. Is that what others get also? Yeah, and yes, that was the only efficiency I was also going to suggest. So the number 2000 is distracting.
Yeah.
We can subtract off 2000. And then only other thing I would say is you don't even have to search for the 3 numbers which add up to. 1 second.
Yes, sir. So we just multiply 23 into 3, which like 69 and then 39 plus.
Exactly. You don't have to find which 3 numbers add up to 23 or 69. Okay, yeah. So 3 plus 11 plus 17 plus 27 plus 29 plus 39. Now that is the extra on top of 2000. So there are 3 numbers whose average is 23. So it's 23 times x. Sorry, 23 times 3. I'm sorry, 23 times 3. And then there are 3 numbers whose average is x. That's what I'm trying to find out, right? What the x is, x times 3. And yes, exactly like what you said. You subtract the 69 and then divide by 3. You should get x as 19, I believe. Can others also, anyone get a different answer than 19, Precious? What did you get? You got 19 as well on this one?
Wait, sir, I didn't attempt this one.
Oh, why not?
There were 2019.
Yeah, that's what, 19. On top of that, you have to add 2000. Therefore,
Oh, wait,
2019.
sir, yes, sir. So, sir, I did this, but sir, for some reason, I don't remember doing it. I'll just check my answer.
Okay, all right. But I hear a couple of others also agreeing with 19, so it must be right. Okay, cool. So question 6 that was. Question 7. Sukrit, you want to do question 7? Or actually, what is the answer that you got before you go to the method?
Sir, I got 3.
You got 3. Okay. Vishwita, do you agree or
Yeah.
disagree with him?
I couldn't solve this question. I was unable to get
Fine.
this.
No problem. First, let's go ahead and discuss who all got the same answer, who all got a different answer, whoever was able to do. Vishwita, did you do it and did you get
I
it?
got 3, but I
You got-
kind of like, it's been a while since I did it, so I kind of forgot how.
Okay, all right. So in a way, it's good that you did the homework long ago, as soon as it was assigned. But also, I would request all of you to just, if you've done it long ago, as in a week ago or something, just before class that day in the morning, just recap what you did, so that it's useful for the class discussion. Okay, all right. Arjun, what about you? What did you get on this one?
I got 3.
You got 3 as well. Okay, so Arjun, you want to describe what you did?
Sir, let me think, sir. When I did it a long time.
Okay, all right. Sukrit, why don't you describe what you did to arrive at 3?
Sir, so what I did was I just like did
Sir, I remember that
Arjun, please. I ask everyone not to talk outside turn. Now Sukrit is talking, let him allow. Okay, I gave you a chance. Okay, all right. Sukrit, continue, please.
Sir, so first I noticed that it's like 23 threes, so that's an odd number. So I did it with like 3 threes and 5 threes, and the remainder was still 3. So I just guessed it might be 3.
What do you mean? You're dividing it by 32, right?
Yeah.
So, so there are 23. There are 23 23s. Okay. So there are 46 digits.
Yeah.
Okay. Please describe again what you did. Maybe I did not catch what you said.
So so that's an odd number of 23s. So 23.
Yeah, odd number of 23s. Okay.
So then I did it for 3 23s.
Mhm.
23, 23, 23 divided by 32. The remainder was 3. And then I did it for 5 23s. The remainder was still 3. And then I did it for 7 and it was still 3. So it will even
Okay.
for
So for 3 23s, you actually divided and saw. For 5 also, you actually divided and saw.
yeah.
And so on. Okay. All right. Arjun, what did you do? You were saying something, Arjun.
Yes, sir. I'm saying that I checked for the first 2 or 3 ones, and then I saw that there was a repeating pattern, and it went till 3.
Okay. All right. Anyone else? Any other method? Nitya, what did you do?
My method was the same, but I'm getting a different answers.
What is the answer that you are getting?
7.
Seven.
So it was 17, 7, 1, 23, 17, 7.
Okay.
And
All right, fine. Let's discuss. Okay. So the way to do when you divide by 32 or any power of 2. Yeah. Sorry, Akshay, you were saying? I thought someone spoke something.
Sir, I'm getting 1.
You're getting 1, Akshay. Is that what you said?
Yes, sir. I'm getting the answer 1. Yeah.
Your connection is not smooth. You're saying your answer is 1. Okay. All right. Let's discuss. Okay. So what is the divisibility rule by 2? We just look at the last digit, if it's even or not. Very simple. What is the divisibility rule by 4? We look at the last 2 digits. Correct. So if I have a number 693, okay, or even why 693, we'll say 78,693. We just have to test if it's divisible by 2, or rather, no, not divisible by 2. If it's divisible by 4, the answer is clearly no, because it's an odd number. But what is the remainder when you divide by 4? Arsh, what would you do in such a case?
So I think it'll be
Divide by 4. Okay. Divide by 4.
3 will be the remainder.
Why?
No, 1 second. 93. So 80. So 1 will be the remainder. 1.
1 will be the remainder. Why? Because you look at only the last 2 digits.
So yes, sir. So 92 will be the last, and then add 1 to that. So
correct. Why is it that you look at last 2 digits for 4? And similarly,
That's a divisibility rule of.
That's the divisibility. But why is that the divisibility rule of 4? And why is it for 8? Why should we look at the last 3 digits? And if it's divisible by, to check for divisibility by 2, or what is the remainder when divided by 2?
So
we
there
look
was
at the
some
last digit.
theory, like they derived the formula. So I forgot how they derived it.
Okay.
There was
Because sir, I'm sir.
Go ahead, Akshar. Yeah.
So because every 100 ends in 4. Every 100 is divisible by 4. Like even 100 is divisible by 4, even 200 is divisible by 4, even 300 is divisible by 4.
Exactly. So what he's saying is every 100 is divisible by 4. So we know that 78600 is perfectly divisible by 4. Right? Every 100 is divisible by 4. Therefore, for checking when divide by 4, you only focus on the last 2 digits. Similarly, to check with 8, we know that every 1000 is divisible by 8. So this will divisible by 8. Right? Because 1000 divided by 8 is 125. Every 100 is not divisible by 8. Every 1000 is divisible by 8. In fact, every 200 is divisible by 8, but that's a different story. Every 1000 is divisible. Therefore, we can just focus on 693 alone and check what is the remainder when you divide by 8. Does this make sense, Arsh? Okay, because with every power of 2, every power of 10, you're adding one more 2 to it, right? Because 10 has 2 times 5, another 2 times 5, another 2 times 5. So which is why 1000 is divisible by 8. And similarly, extending the same logic to test if something is divisible by 16, or rather, what is the remainder? You check at the last 4 digits. And for divide by 32, you check the last 5 digits. That's it. So we don't have to worry about anything else. So we'll just look at the number. Last 5 digits are what? 23, 23.
The answer
and
is
then-
1, right?
I'm doing it as we speak right now. Okay. Right. So the 1 digit after that is 3. And now we'll just divide by 32. We'll see for ourselves. So Akshar, I don't know why there's a big lag on your side, or is my connection okay, guys? Vanya, you're able to hear me smoothly?
Yes, sir.
Yeah, just Akshar's connection alone seems to be a little off today. Okay, all right. So 32, okay, 0, then, okay, in fact,
Where did we get the number 3232?
32320. Yeah, so in fact, I can make it 32000 plus 320, which is divisible by 32. I don't have to divide, plus 3. This is divisible,
Where
this
did-
is divisible.
So I didn't get why you using 32323. Like, why aren't you extending it?
I'm using only the last 5 digits as we spoke.
Oh,
For
okay. Yeah.
divisibility by 16, I'll look at last 4. For divisibility by 32, I'll look at last 5. So the last 5 happen to be 32323, of which 32,000 is exactly divisible. 320 is exactly divisible. I don't have to do the long division and waste time. And 3 is the balance. Nitya, does this make sense to you?
Yes.
Okay. All right. So let me ask a question. So to test divisibility by 128, how many last digits will you look at?
Me?
Let's see. Let's give it to 1 year. 1 year.
7.
7. Right? 2 power 7. Therefore, last 7 digits. Okay. All right. So that was just 1 second. Yeah. What's up? Okay. So that was question 7. Okay. Question 8. 1 year. We're able to do this square and rhombus wala question.
Yes, I wasn't able to do this.
Okay. All right. Let's see. Purav, we're able to do this.
So
We're able to do this square and rhombus. Purav. No. Okay. All right. Let's see. Prashast, what about you? No. Okay. Anyone else? Arjun.
sir, I wasn't able to do this.
Okay. Nitya.
I got 10.5 centimeters square, but I'm not sure if it's the correct answer. Or
10.5. Okay. All right. Since multiple of you could not do it. Vishwita, yes. go
Sir,
ahead.
sir, I got 9.
You got 9. Okay. And
11.
Vishwita.
Sorry,
11.
I got
Vishwita
11.
got 11. Okay. 3 different answers. 10.5, 9, 11. Okay. Let's discuss. Okay. Diagram shows square, which has a radius
I
area
got
of
30.
13. Akshar, do you mind
Sir, I
checking
got
your
13.
internet connection, because it's very
Yeah.
lagging? Okay, so it's okay. Please, it's a bit annoying as well. Okay, so please check. 13, you said, Akshar. I'm just writing it down. That's 13. Okay, so 4 different answers. Excellent. So let's see. PQRS has an area of 25. So clearly the side of the square is 5. So this is 5. This is 5. Okay. And since the square ends here, PQRS, this is also 5. So we know the square, and SR is also 5, right? Which I have not marked. But anyway, let me just mark SR here. Thoda. So this is also 5. I mean, the entire SR is 5. Okay. Area of a rhombus is what? Area of a rhombus is base into height. Area of any parallelogram, if I take any parallelogram, area of a parallelogram is base into height. So the slant one, or rather, I may just call, okay, suppose the slant height is L, right? L for length, right? L has no meaning at all. B into H is what the area is. So L is not meaningless. I would say not necessary to calculate the area. So the vertical height, perpendicular height is what counts. Now, by that logic, the rhombus has an area of 20, which means the height of the rhombus is 4. Okay, which means, let me mark this PQRST. Okay, okay, all right, fine. Let me mark this point as V. Okay, so this is 4. Okay, and therefore this top one is 1. Top one is 1. Okay. And then we know that this is Okay, so this is 5. So the rhombus side lengths are 5. So this is 5, this is 5. The rhombus side lengths are 5, right? And therefore, if I drop a perpendicular from here onwards to here, okay, so since this becomes 4, both the red dotted line and the green dotted line are 4 each, and therefore by a 3, 4, 5 triangle, the bottom becomes 3. So this becomes 3, and this balance becomes 2. Are we all clear now on this one, on this picture? Okay, now we want the area of this shaded region, right? So if I extend this, so this will be 2 here, and also I'll mark this as 2 and 3. Exactly that same above. 3, 4, 5 is the Pythagorean triplet, right? If this is 5 and this is 4, this has to be 3, right?
Okay.
Yeah, Banya?
So in a rhombus, are the opposite sides parallel?
Yeah, a rhombus is a parallelogram. In a parallelogram itself, the opposite sides are parallel. A rhombus is a special parallelogram, right? Obviously, not only are the opposite sides parallel, they are also equal, even in a parallelogram, and all the more so in a rhombus. And in fact, all the sides are equal in a rhombus. Why this fundamental question, Harsh? Yeah. I mean, I don't mind you asking, but yes, it's a very obvious thing, right? Yes, they are parallel and they are equal. All the sides are equal in a rhombus. And Manya, 3, 4, 5 is okay. Why are you surprised about 3, 4, 5?
I forgot.
Okay. Yeah, 3, 4, 5, we cannot forget, guys. Even, in fact, I want you guys to remember more triplets like 5, 12, 13, 7, 24. 3, 4, 5 is the most fundamental, I would say, right? You should grab such opportunities. 5, 12, 13, 7, 24, 25. And let's recap these 9, 80, and 81. We know how to generate this. We have gone through this, right? If you take any odd number, you square it. Sorry, 9, 40, and 41. If you take any odd number, if you square it and then divide it into almost 2 equal halves. 9 square is 81. 81 as 2 consecutive numbers will be 40 and 41. So that'll be a triplet. Nitya, I don't know whether you caught up on the old videos. You know this Pythagorean triplet business, right? Okay. So these are very common ones, which all of you should know in the fingertips, but also a few non-common ones like 8, 15, 17 is a triplet. Okay. You should look for it. You should know it. You remember one of the questions we did, I remember there was some isosceles triangle, something was 8, something was 17. I remember this very recently. One of the questions, 8, 15, 17 came up. And then if you can remember 20, 21, 29, that's also. So all of these are, you save 20 seconds, 30 seconds if you know this. And in a very short test, it makes a significant difference, right? In a 40, right? 25 questions, 40 minutes, right? So you have to be very sharp and very quick. Okay, all right. So where are we? So we got all these dimensions. Now we just have to find the area of the shaded region, which will be, which we can divide into 2 parts, right? We can say this trapezium, and then this small rectangle here. The rectangle here looks like a square, but it's more like a rectangle, right? It's 2 into 1. So, and then this trapezium here, right? The trapezium. So let me just draw the trapezium alone separately on the side here. So this is 5. I'll draw it a little bigger so that you guys can see. This is 3, and then this portion is 1, and this portion is 5. Okay. So this is the exact same trapezium I've drawn. I'll just label this so that you're able to associate P, S, V, and Q.
So how did you divide the Q and R line into 3 and 2?
Because of the 3, 4, 5, right? I drew a perpendicular from U. So from U, I drew a perpendicular down here.
Yeah.
So that was 4. You agree, Vanya?
Yeah, because
5 minus 1.
Oh, okay.
And therefore, this portion became 3.
So why can't we simply just calculate the area of the non-shaded region over there and find the area of the square?
Either way, it's the same effort, right? Trapezium plus a okay, let's do your way also and just check. We should get the same answer. So let me just complete this diagram again. So this is, this looks like 2, sorry. And this other portion is this 2, right? It looks more like 1. Okay, so this is the 2 into 1 that I said. And then this is, what is the area of a trapezium? The height into the average of the 2 bases. So this base is 1. Okay, and this base is 5. And the height is 3. Height is 3. So let me just block this. So this is 2 and this is 1, right? So this area was 2 into 1, which is 2. And this area was height into average of the two bases, 5 plus 1 by 2. Okay, so 3 into 3, which is 9. So 9 plus 2, 11 is indeed the correct answer. I know multiple people called out. Who called out 11? I'm sorry. Yeah, well done, Vishwita. Okay. Is this pretty much what you did, Vishwita?
I did it a bit differently. I found out the triangle, and then I found the area of like the triangle, minus it from 20, like the area of the okay, I forgot what the rhombus, and then I minused, which was 14 for the area that's like connected to the,
Okay.
and then minus that from 25, so 11.
Okay. It's a slightly more convoluted, right? Or
Yeah.
Either way, yeah, as long as you're able to consistently do it. Arsh was describing another way. Arsh, what was your method? I mean, after arriving at all these dimensions,
So I
Arsh, you
just
said,
found out the rectangle and the triangle area, simply like half base into it plus 4 into 2. So like 2 into 3, 6 plus 8, 14, 25 minus 14, 11.
okay, which triangle you guys are talking about here? I'm sorry.
So like you've labeled the 4 and 2. No, so like that's
I've labeled this point as X. QVX, is it?
QUX is a triangle and RVUX is a rectangle there.
Yeah. Or in fact, you can do one shot. You can find the trapezium RQUV and subtract it from the square. That's also fine.
Or we can also find out RST and then subtract it from the entire area of that and then subtract that. There are many methods.
Yeah,
many
I found
methods.
RQ.
Go ahead, Vishwita.
U-
RQUV.
I found, yeah, UV
Okay.
subtracted from the
Yeah.
square.
So the RQUV, the trapezium. So let me just, if I just focus on, okay, RQUV. So this trapezium, if I focus on this trapezium, the height of that trapezium is 4. Right? You can see the height is 4. 4
I
into
just found the triangle RVT and then minus that from 14, which would be, 20, which was,
yeah,
so
you could do that. Yeah, and then you subtracted that from the square's area.
Yeah.
But you can avoid even one step further. You can directly find the trapezium UVRQ as height times average of the two bases. This top base is 2, the bottom base is 5. So 2 plus 5 divided by 2, average of the two bases, right? So this works out to be 2 times 7, which is 14. So the trapezium area is 14, subtracted from the square area, which is 25. Either way, you arrive at the same answer, 11. Okay, but yes.
Different method, and I got 9.
Can you describe your method? We'll find your mistake, or rather I'll ask. So is this completely clear, guys? I'm going to erase all of it and then we'll go through Sukrit's method. Okay, I'll erase all of the Sukrit. Yeah. Okay, go
Sir,
ahead.
so
Yeah.
first, I labeled the line from U perpendicular to QR.
Okay, let me just draw that line. So U to QR. Okay. Okay.
And then from like a direct line from S to R.
S to R as well. S to R. Okay. Okay.
And then I just labeled like I said, let the height of the rhombus be Y.
Okay. Are you calling this bottom point something where the line from U hits QR? Are you calling this point something? What are you calling?
Yeah, I call that X.
X. Okay, I'll also call it X. Okay. Okay, now go ahead, please. You found these dimensions or you did not? Okay, all right, I'll go with you. You describe what you did. Okay.
Then
right.
I said let the distance from X to R be X.
Okay, so this distance is X.
Yeah.
Okay.
And from the place where that S to R line over there, where it's in
okay. Yeah, this point. What are you labeling it? Can we label it something? V or something? A. Okay. Yeah.
Yeah, sure. Okay.
So could I be back in
So
2
then I said from A. So I said AR is, let AR be equal to Y.
Okay, AR equal to Y. Okay.
And then the triangle UQX be A1.
UQXB A1, this area.
Yeah.
This area is A1.
Yeah, so then even ART will be A1.
ART will be A1. Yeah, okay. So this is the exact same area. It's just sorry, why do you say that? ART will be A1. Yeah, correct.
Because
Yeah, correct. Yes. This is A1. Okay.
so then the area of
The middle portion.
so 25 minus A1 plus Y is the area of QUAR. No,
20
sorry. 25 minus A1 plus Y is the area of QQX.
A1 plus Y. Y is a length, right? Y is the length AR according to you, right?
Oh no, sorry, I didn't label the length as Y. I meant the area of that rectangle.
Area of this rectangle is Y, is it? Okay, all right. So I'll redraw this. So it's okay. Let's listen to his method and we'll find out what the mistake is. Okay. So you're saying this area is Y. This area is Y. Okay. And then you're calling some length as X. The length XR, you're calling it as X. Is that right?
Oh wait, sorry. No. The length is only Y. Sorry, my bad. And then I put down the equation 2 into half into 5 minus X into Y plus YX is equal to 20.
Okay. All right. So let me just do it again once more so that you're consistent, right? So basically, you're saying this small length is X and this vertical length is Y. Is that what you're saying?
Yeah.
The vertical
Yeah.
height is, and therefore this is 5 minus X. Okay, all of you pay attention, huh? Because I'll ask any one of you to find the mistake. Don't think the problem is done. I want you guys to be able to be equally effective to find other mistakes. That's when the learning is complete. Okay, so 25, 5 minus X, all the labeling is clear so far, right?
Yeah.
Okay,
So
all
then
right.
I said 2 and then a box bracket,
Okay,
half into another bracket.
Mhm.
No, not around half. Like
okay.
Okay,
What are you trying to do? The area of the two triangles area, right?
No.
Mm.
The whole rhombus. I'm just like making an equation for that.
Okay, can you describe your statement what you're doing, and then we'll write out the equation. What are you trying to say?
So 2. So the QUX triangle, half base into height, that times 2 plus XY is equal to 20.
Okay, yes, agreed. So the two triangles he has, let me just shade this triangle and the corresponding triangle here. The sum of these two plus the center portion, which has a small rectangle, they collectively add up to the rhombus. That's what he's trying to do. Okay, so let's write up the equation. The area of the two triangles is half into base into height, half into 5 minus X into Y. And there are two of them. And then now he adds XY and he says this sum adds up to 20. Right, Sukrit?
Yeah.
Okay, so let's simplify this. So 2 gets cancelled. So we get 5Y minus XY plus XY equal to 20.
Yeah, so you can cancel out the XY. So 5Y is equal, Y is equal to 4.
Which is exactly what we arrived at also earlier. But just by doing the area of a rhombus is base into height. So what you did is also right, but except that it was longer. Base into height is very simple, right? So therefore the height, at least it's consistent so far. Okay, continue, please.
And then I got that. Wait 1 second. Let me just.
Purav, you're following along so far? All good?
Awesome.
Okay.
I got X is equal to 2.
X equal to 2. Yes, that's all. The same thing as what we got also, right? Separately by 3, 4, 5. So we got this to be 3 and this to be 2.
So then 25 minus 4 into 2 minus half into 2 into 4.
Okay,
That's
so 25, which is the area of the square, minus what?
4 into 2.
What is the 4 into 2? The area of the rectangle.
8. 8. Oh,
no.
yeah, yeah.
The rectangle UAXR, that's 4 into 2. And then plus half
No,
into,
minus.
you're subtracting from the square area, you're subtracting the rectangle and the small triangle, right?
From the 25 square, I'm that.
Yeah, so I'm subtracting two things, which is why I put the brackets. 25 minus two things, the rectangle, which is
Yeah.
4 into 2, and the triangle, this triangle in green, which I've shaded, half into base into height.
Yeah.
And what do we get here? We should get the same thing, right? So 3 2s are 6, 4 2s are 8, 25 minus 14, which is 11.
Yeah.
What is the mistake?
I think it was just the last part calculation error.
Last part calculation error. Okay, all right, cool. But yes, so this is how you debug in case there's something wrong. We just go step by step and then find your mistake. All right. Why am I not able to add extra pages here? Okay. All right. So let's go to the all clear, right? Precious, you're able to understand this fully, right? All the different methods. Okay, good. Next question. Question 9. Arsh, were you able to do question 9?
No, sir.
Okay. Arjun, what about you?
So I wasn't able to understand it only, like which one of these shapes was removed. So I was confused, like which shape was removed.
Okay, so there is a shape like this, right? There is a shape like this.
Yes, sir.
Yes, sir.
Exactly another shape like this. Okay, so in fact, let me do one thing. Let me just paste another one like this. Okay, so you have this object, you have this object. Okay, you make this one ulta. You make this one ulta, right? And you make it sit here on top of like this. Does it make sense? Doesn't
Oh,
make sense.
now it does. Sir, I didn't understand what they meant by one of these shapes.
Yeah.
Sir, I hadn't gotten to this question yet. So just let me
Could you explain it again?
Sir, I got 46 as the answer.
Okay, all right. I'll explain it again once more. Don't worry. 46 is the answer. Okay, one of them is calling 46. Okay.
I got 38.
38. Okay. Any others?
So Justin.
Okay. All right. So meanwhile, I'm trying to explain how you get this shape, right? So you make this. Okay. So I've drawn 2 blocks, right?
Sir, I'm getting 39.
39. Okay. All right. So you bring this piece. Whoever did not follow the picture, you bring another piece, which is this, right? 2 broken pieces. Now, isko ulta karo. Make this tilt this 180 degree upside down. Okay. And then, excuse me, try to fit it here in this portion. So this square comes here. This square comes here. Are you able to imagine this? Yeah.
So I'm not understanding if the hollow part is going in the hollow part or the full part is going in the hollow part.
So now I understood. Now I got it.
Okay, Precious, you want to describe in your to Arsh how you are describe? Yeah.
Okay, 3D. It might not be as easy to imagine, but so can I just annotate on the screen?
Go ahead,
Yeah.
please.
So forget 3D.
I'll erase this. I'll erase this if it's
Yeah.
helpful for you. Okay, go ahead.
So think of it like this. Think of this as one shape, okay? And think of this as the other shape. Just
I
present
got
them.
it. I got it.
Yeah.
Oh,
Then the other one goes like this, but perfectly interlocking and stuff.
I
Yeah.
got it. It fits into it like a.
Yeah, but not like this. Sorry. Not sitting on the other exactly. Upside down.
So got it.
Okay, all right. Yeah. So unfortunately, people have to imagine it for themselves, right? So yeah, correct. So good that you got it. But anyway, once you got that, thankfully he has drawn. Okay, can you remove this? I'm not able to erase this, Precious. I always have this problem. Someone else annotates, I'm not able to erase.
Oh, yes.
Can you erase it?
Yes.
Okay, but once you do it, now it's easy, right? So from this angle, if you look at the view from here, it just, let's say you are looking at it from infinity, right? It'll appear as 3 blocks like this. 1 block, right? And another, like, it's almost like 1.5 squares like this. Do you agree that when I view from this front view, so this is front. So from the front, if you view this object, let's say you're standing at some 10 meters away or a far distance away, this object will look like this. Do you agree? Are you able to visualize this? Or are you able to visualize this? ऊपर से देखोगे तो ऐसा दिखेगा. This square portion is this square portion. Okay, and ये जो पीछे का ये जो है ना, sorry, Vishmita does not understand Hindi. So this portion behind, this green portion, okay, that appears as half of this because half of this is blocked through this. Are you able to visualize, Harsh? Pakana? Okay. And similarly, when I view from this angle, from the side angle, also exactly same. It'll appear, this will appear like a square like this. Okay. And then there'll be another small piece hanging out here, which is half the square. Right?
Sir, actually, can you change my answer? I got 46, but now I got 38.
38. Okay, so a couple of you getting 38.
Yes, sir, I'm getting 38. I'm getting 38.
Okay, so whoever called 39, was that you initially, Prashast?
Sir, I
No, sir, I didn't call 39, sir. I'm saying 38 now.
Okay, you also.
I'm saying 38. I wasn't
Okay.
able to answer earlier, but now I found 38.
Yeah, I wrote out all the answers, but I didn't mark who is which. Okay, so there are 338, so very likely it's right. And then 139. Let's see. Okay, so all of you able to visualize this, right? So, so from the 4 sides, it's going to be the same picture, which is 2 by 2 by 2 by 2, and then this is 1/2, right? Right? So
Okay,
this
sir,
is.
can I share how I did it?
Just 1 second. Let me just finish the process. So 6 into 4, which is 24 from the 4 sides. Okay. Now, from the top portion, okay, all right. Precious, can you pick up the top portion? So from the top portion, what will the area be?
So let's think about this way. So the top and the bottom portion will have the same area.
Exactly.
Exactly. So
And what is that area? Yeah.
since it's a 2 by 2 by 2, that means, like, let's just look at the squares, okay? So if these squares were separate, then 22/4 plus 22/8. But they are overlapping by 1 because of this tiny hollow. So it's just come inside, okay? That you have to visualize. Since it has come inside, yeah, so can you just like draw that?
So,
yeah,
yeah.
perfect. So then 3 over there, 1 in the middle, so 7. So 7 plus 7, 14. And so should I see the rest?
Yeah, that's it. You just have to add. Upar wala, on the top, we have, like he said, right? There are 2 squares. There are 2 squares, which each with area 2 into 2. So 8. But from this, you subtract off the overlap area, right? Either way, either you can look at it like this, or you can look at 1 full square and then a 3/4 of a square. 4 plus 3 is 7, or 8 minus 1 is also 7. Either way you want to look at it. And symmetric picture downstairs also. So 24 plus 14 indeed is 38. Whoever
Sir,
got
did you
39,
get
very able to find your
24?
mistake. Huh?
Yes,
24? 24?
Oh, it's 6 into 4. Okay.
6 into 4.
Can you once repeat it?
From the very beginning? Okay, very able to visualize the front view and the side view, Vanya?
Yes,
The-
I voted till like 6 into 4, 24, but then 7 into 2, I got confused.
Okay,
like-
all right. In fact, that's one of the easier portions, right? At the top, there are 2 squares, right? There are 2 squares. This full square, this full square. Precious, it's okay. Let me just finish it. I know you wanted to describe. So this square, okay, and then there is another square like this, right, Vanya?
Yes, sir.
There is a small overlap portion between the 2. which is this small portion here, and which is a 1 by 1. Right? So I'm trying to find per top portion. You add up the two squares, which is 4 plus 4, and subtract off the common portion because it's getting double counted. Yeah, Vanya, does it make sense? Vanya. Are you there, Vanya?
So, but I didn't get why you did 6 into 4. Like I got 6 into 2 for the
The
two
four
sides.
sides are all all the four sides look like 1.5 squares, like the way I've drawn.
Oh, I got, yeah, okay.
I didn't hear it. My internet was not stable.
Okay, so at the top, you agree there are two squares, each with area 4, 2 by 2. Okay, and therefore the sum of the two squares is 4 plus 4, which is 8. But then there's overlap portion, the small little square here, which is getting double counted, right? We'll have to subtract that. So hence 8 minus 1, which is 7.
Oh, okay.
Okay. All right. I'm just trying to see if there's another question I can make out of this. Okay. Okay. All right. Let me just ask one simple question. Now I take these two objects, right? I melt it and form one cube. Okay. I take the two broken objects that we joined right now. I take them apart. I melt it, and from the molten liquid, I make one big cube. What will the side length of that cube be?
Side length.
Side length of that cube be? Can you all work it out and tell me? You can tell me it won't be a perfect number. You can tell it me in powers.
So like both of the cubes will be melted.
Correct. Both of the two broken cubes are melted or molten. Okay. Whatever that. Nitya, both of the cubes are melted or both the cubes are molten? Which is the correct English?
Both of the cubes are molten.
Are melted. Yeah. Okay.
So is
And
it
then
like
from the
cube root?
Not molten.
Yeah, and from the molten liquid, you make a cube, one big cube. And what is the side length of that? And yes, Arsha, I heard your answer. That's correct.
Yeah, so like nothing more than that.
Nothing more than that, right?
14 ka cube root.
14 ka cube root. For each the volume of each of those cubes is 7. And therefore, the total volume is 7 plus 7, which is 14. So 14 is the volume of the big 14 centimeter cube is the volume.
I'm getting 14 cube roots.
14 power 1/3. Okay.
Yes.
And what will okay, let's call this as x. Suppose this is x. Okay. In terms of x, what will the length of the main diagonal in the cube be? You understand the main diagonal? From the bottom left to the top right. That main diagonal. What will the length of that be in terms of x? So if I have to draw a picture, when I say the main diagonal, I mean this one. So let me just draw a cube. It should be obvious, but in case. Okay. So this is hidden behind the picture, right? So I want the distance between A and B. Okay, if this length is x. The side length of the cube is x. Find the length AB. Purav, can you take this?
Yeah, so I have to find the surface area of this, right? Like
not the surface area. Find the length of AB. Length
of AB.
Yeah, in terms of x. We know the x is 14 power 1/3. We just got that.
But I'm
in
getting
terms
my answer in the room. Is that okay?
Akshar, did I ask you? Okay. Please, all of you, stick to your turn, please.
So
But
I
also-
didn't get what you mean by like.
Yeah, so how do we find the length of AB? They're not on the so it's like a diagonal.
The main diagonal, yes, the main diagonal AB. Yeah. Sorry, Arsh, what was your question?
So I didn't get how we Will the diagonal pass through the cube and like that?
Yeah, through the cube. So just imagine you're sitting in a room from the lower one corner to the upper other corner. That's called the main diagonal of a cube or a cuboid. Okay, Akshar, meanwhile, I heard your answer. I think I heard it right, but yes, hold on. Let's give it to Purav. If he does not, then I'll give it to you. Purav, the question understood, right? In terms of x, find the length AB. So for example, you might say, I'm just saying, for example, you might say it is x into 7/3, something like that. I'm just making up some random thing. That's not the right answer.
So 2/3 x.
2/3 x. Doesn't it have to be more than x, first of all?
Sorry, sir. Will be not 2/3, sorry.
Akshar, meanwhile, can you
It's just
chat me your answer?
Recurring
Akshar,
3x. So 4/3x.
4/3x. Okay, Akshar, meanwhile, chat me your answer. Purav, why 4/3x? Can you explain? I'm not saying it's right or wrong.
So based on visuals, I'm saying this. I don't know how.
Okay, all right. Why not 5/3x? Why 4/3x?
So suppose you put x, like just draw x as a diagonal between each, and you you draw a diagonal between the two.
So
And
this main diagonal, this length is what I want from A to B.
So it looks like 4. Wait, so from A to
Okay,
means
this it just happens to be overlapping with this.
words of 14 raised to the power.
Okay, Vishwita, any answer?
No. I'm like
Okay,
still trying to work out like how to find.
all right. Akshar, please explain to class.
So is my answer correct?
Your answer is perfect. Yes. Go ahead, Akshar.
Yes, sir. So, so we know that the side length of like a cube is √314. The cube √14, right?
Cube root 14. Yes, that's the side length. Yeah.
So I didn't
Yeah.
hear his answer, but is the answer like 14 raised to power 1/3 into √2 into √2?
Okay. So so 14. In fact, let's write it in terms of x itself. So it's not x into 7/3 or x into 4/3, and it is not Arsh's answer. X into √2 into √2. You said.
Yeah.
But then there will be 2x, right? Why do you have to say √2 into
Oh,
√2?
yeah, sorry. Yes, sir. 2x.
Yeah. No, it is not the correct answer. The correct answer is √3x. Okay.
So √3x is the formula that I remembered on the top of my head.
Correct. But why are we getting that formula?
So I don't know, sir. I memorized this formula.
Okay. All right. Can someone be able to derive that for any cube, the main diagonal length is √3x?
Working on it, but sir, I think I have an idea.
Okay, go ahead, Prashant. Okay. No, until you are completely clear, let's not discuss. If you want it, I'll give everyone 30 seconds. Okay. In fact, it's going to be a prove that question. So if the side length of a cube is x, prove that the main diagonal is length √3 into x.
Excuse me, sir.
Yes, Nitya.
Can we simply manually solve it and then show like the method?
Yeah, of course.
Okay,
Yeah, go ahead.
That then.
Sorry.
I've done that, then I just got the answer, like as you said it.
Okay, please go ahead and describe why we get √3
First,
times
let's
x.
take the triangle AP and can we give a point to?
In fact, let me label all the points. So T, U, V, all of this. Okay, all right.
So let's take a point APT.
APT. Okay, all right.
Yes,
APT.
that's a right angle triangle. So what we can do here is simply find AT now. AT will be root of 2x squared or x √2.
Yeah.
The next thing to do is find BT. Well, we know BT is x because it's a cube.
Correct.
Now, to find AB, think about it this way. If you remove the excess material and only leave the outline, so that it becomes a triangle in the horizontal plane, in a plane, a 2D shape basically, you'll find that ATB will be a right angle triangle. So
correct.
we already got, and AB will be the hypotenuse of that triangle. So we've already got x root 2 and x. So if we find the hypotenuse using Pythagoras theorem, we get the answer as x root 3.
Excellent. Very well described. Okay, let me just redraw this because it just so happens the main diagonal passes through this. I want to avoid that confusion. Yeah, very well described, Nitya. Okay, all right. So let me just draw another simple cube here. So hopefully this time it won't pass through. Okay. So this is the top portion of the cube. And this is the bottom portion of the cube. Okay, so, and then I'll draw the hidden lines as well. Okay, the hidden lines here as well. The
Sir,
hidden lines
I mean,
here.
I have like a reason for this, but sir, my reasoning is like very strange. Sir, just
Okay.
tell me if this makes sense, sir.
Since Nitya just described, let me just describe this once and then I'll listen to you after that. Is that okay, Precious? Okay, okay, good, thank you. So I'm calling the top portion A, B, C, D. I'll call the bottom one P, Q, R, S. And obviously the main diagonal is not A, B right now. So it is instead S, B. So the main diagonal is running from S all the way here to B all the way there. Or it could be from A upper to R at the bottom, right? Either way. So I'll just mark the main diagonal. Any 2 points on the main diagonal, S and B I'm taking. Okay. Now what Nitya described was also right, but I'll do an easier way. I mean, it's the same thing, but it's easier to visualize. Let's look at the diagonal SQ. Okay. On the bottom, right? So on the bottom plane, SQ. So this length is
That'll
X.
be root 2x, right?
That'll be root 2x, yes. So this is X and this is X. And therefore, this is very simply root 2x. It's a 45, 45, 90 triangle. Now let's look at the triangle SQB. So we'll focus on this triangle SQB. Okay. So in this triangle, if I connect S versus B, again, it seems like it passes through C, but C is somewhere protruding outside, nothing to do. If we focus on the triangle SQB, it's again a right angle triangle because this angle in 3D is 90 degrees. And this is X. This length is X. Okay. Therefore, SB is the hypotenuse as she described. SB square is root 2x, which is the base diagonal, the diagonal on the floor, and then the height, which is X, which forms the other part of the triangle. Square by Pythagoras theorem, which comes out to be 2x square plus x square, which is 3x square. And therefore, SB is root 3 times x. Is this clear to everyone?
Yes.
Vanya, clear to you?
Yes.
Yeah, and this can be extended to a cuboid as well, instead of a cube. So for example, let's say this is not x and x, but a and b. Then this will become not root 2x, it will become root of a square plus b square. And let's say this height is not x, but c. Then the same logic, it will become square root of a square plus b square plus c square. In the case of a cube, a, b, and c are all x, and x. Therefore, it's root 3x. Right? In a more general setting like a cuboid, it'll be square root of a square plus b square plus c square. So exactly like in 2 dimension, it'll be square root of a square plus b square. You're adding another dimension to it, therefore plus c square and then root of that. Okay. If this is all clear to everyone, Prashast, yeah, what was you were going to say something, Prashast?
Okay, so just forget that because so that just like went. So just forget that.
Okay. All right, cool. But this made sense to you, right, Prashast? How we arrive at this? Okay, cool. So this was question 9. Question 10. Okay, Akshar, did you do question 10? Tea and coffee, tea and eclair.
So can you paste the question?
I pasted it, yeah.
So no, I didn't do question.
Okay. Sukrit, what about you?
Sir, I got 7.5 euros.
7.5. Okay. Vishwita, same. Okay, Vanya, what did you get?
Yeah, I also got 7.5.
Okay, can you describe what you did, Vanya?
Even I got 7.5.
So even
Okay.
I got 7.5.
Okay, cool. Vanya,
Yeah.
can you describe? Good one, yeah. Please describe. Unmute and describe.
So 1 second, I did it a long time ago. 1 second, I'll just think of it. So I think I did like a trial and error method. So for example, if I took like cake as 3.5.
No, trial and error won't accept because very difficult and time consuming, right? So
Actually, I don't remember the method. I like did it a long time ago.
okay, Sukrit, can you describe what you did?
So could I?
So first, I just like, so t plus cake equals 4.5,
Okay.
t plus eclair equals 4, cake plus eclair equals 6.5. So then the difference between the two is 0.5 between cake and eclair.
Okay. So this difference is 0.5, you mean?
Yeah.
Okay.
So from that, so two numbers with a difference of 0.5 adds up to 6.5. So then I knew it will be
Sir, just hold it.
3.5 and 3.
Okay. So by adding these two, you get 2C equal to 7. Therefore, C is 3.5. Therefore, E is 0.5.
Yeah.
Right?
It's a way easier method than this. Like,
Exactly. I was just
I have
going
a
to
very
come to that.
easy
so 2t plus cake plus eclair is equal to-
Please. Let's stick with John. I'll make sure everyone. I was going to give it to Arjun. Yes, yeah. C is there, E is there, and then from C and D you can solve for T, and then you add it all up, right, Sukrit? Yeah, that's good, but you can do it faster. Arjun, what did you do? Tell me.
Sir, I added T plus C plus T plus E plus C plus
Exactly.
C plus E.
Add all of them, you get 2T plus 2C plus 2E. So you don't care about the individual values.
Yes, so that is 15, and then you just divide it by 2, so you'll get T plus C plus E is 7.5.
Yes, makes sense. Arsh, I think that's what you were also going to say, right?
Yes, sir.
Okay, yeah. So this is a symmetry trick you can apply. Is this clear, Sukrit? Okay. So okay, I'll give another problem. Just 1 second. Okay, all right. A cuboid. I was just trying to make up a problem. Okay, so I'll dictate and also scribble something here, right? So have a cuboid. And the cuboid has how many faces does a cuboid have, Nitya?
6.
6 faces, right? 3 pairs of faces. But each pair, the 2 faces will be same. Okay. Now the three distinct faces, have areas of 5, 13, and let's say 17. Okay. Find the volume of the cuboid. Okay. Find the volume of the cuboid. Okay. Again, you can leave your answer in terms of decimals. That's fine. Decimal are in powers or whatever. It doesn't. Okay. All right. Let me just see if I can give a better question. Okay, fine. Let's stick with this itself. It's okay. Let's stick with this, and you can answer won't be a perfect number. You can give it in terms of powers and irrational numbers, just like you described last time, right? 14 power 1/3, something like that is fine. Or root 3 times that. You don't have to calculate the decimal value. Arsh, your camera is off. Are you on?
Yes, my internet was very unstable.
Okay, all right. Okay, Akshar, you have anything for me?
So can't it just simply be like area into one of the... Oh, no.
I think isn't it supposed to be 17 only?
It's supposed to be what? Sorry? I'm not.
So
I didn't-
can't it be just can't it be just 10 times?
I'm not following you at all, Akshar. Your internet is very bad. Can anyone make sense of what Akshar is talking?
No, I don't think he's saying something right now, though.
Akshar, your internet is bad. Tell me.
So
Or you want
I'm
to check?
getting 1105.
1105. Okay, all right. 1105. Like this, Akshar? 1105. Okay. Anyone
Yes,
else?
sir.
Anyone else? Yeah. Nithya, what do you get?
Sir, I think it's root 1105.
Exactly. That's a small mistake he did. Yes. So the three sides are, let's say, A, B, and C. Okay. So let me just mark the cuboid, something like this. Okay. So let's say this surface area is 5. Let's say this is upper is 13 and this is 17. Okay. So you have, let's say, three sides, right? A, B, and C. Okay. So the product of A and B is 17. Product of B and C is 5. Product of A and C is 13. By the same logic, there's a tea and biscuit wala problem that we just saw. There everything was addition. Here everything is multiplication. I can multiply all three of them. I get A square, B square, C square as 17 into 5 into 13. And the volume I need is square root of that. So you forgot the square root, Akshar. So square root of that, 17 into 5 into 13, which is indeed 17 times 13 is 221. How do I do 17 times 13 quickly, Nithya? How do I do 17 times 13 quickly?
17 into 10 plus 17 into 3.
Okay, any other ways? Yeah, 170 plus 51, that's a quick one. Any other ways to do 17 into 13?
Sir, you can do 7 into 3 plus 1000. No. Sorry, wrong.
Okay. Okay, I was
Sir, I
thinking.
did as 130 plus 13 into 7, which is.
Yes,
Okay.
sir, and I was thinking that.
Okay. I was thinking A plus B times A minus B, which is A square minus B square. So 225 minus 4, which is 221. But yeah, so either way, right? Any efficient way is fine. 221 times 5 is 1005, was it? 1105. 1105. Uska square root. Yeah, Akshar, found your mistake? Square root. Yeah. Okay, well done, Nithya. Okay, cool. That was this. No, that was not the last question. There's one more question, right? And then we have to come back to that more difficult question, which I want to spend some time on. Question 11. Let's see. Vishwita, what did you get on this one? Two triangles.
I got 720.
720. Okay. Prashant, agree, disagree?
Sir, I wasn't able to solve it.
Okay. Anyone else? Akshar, what did you get? Okay, Akshar is gone. I mean, meaning his internet is bad. Okay. He's unmuting. Akshar, you're saying something?
Yes, sir. I got 800.
800. Okay. Sukrit, what about you?
Sir, I got 720 as well.
720 as well. Okay. Panya?
So 720.
720. Okay. All right. So let me just quickly do it in the interest of time. Let's take this inner, let's call this A, B, C, D. Okay. So we know A plus B plus C plus D is 360. Okay. Now the same A, B, C, D repeat here at the vertically opposite angles, A, B, C, and D. Right? Now the angles that he is marking, all the gray angles he's marking, right? So in fact, let's call them W, X, Y, and Z. Okay, W, if this is X, this is also X. If this is W, this is also W. Okay, this is Y, this is also Y. And this is Z, this is also Z. Okay, so what we want, what rather he wants, is 2 times W plus X plus Y plus Z. Okay, and we know that if you add up all the angles in each of those points, it's a circle. So what do we know? We know 2 times A plus 2 times W plus 2 times B plus 2 times X. Okay, in other words, A plus B plus C plus D plus W plus X plus Y plus Z is at those 4 points, the full circle, which is 360 times 4, right? And therefore, since A plus B plus C plus D is 360, A plus B plus C plus D times 2 would be 360 into 2. So this is also already 360. Okay. And therefore, this has to be 360 as well. Right. And therefore.
No, can you repeat? How?
Okay. Okay. All right. Okay. Do you agree that what I've written here is 360 into 4?
Yes, sir.
You agree. Okay. Now you also agree that A plus B plus C plus D is 360. Right? This is 360.
So I didn't get how that is equal to 360.
Because they are internal angles of a quadrilateral. This inner quadrilateral. There's a quadrilateral inside, right?
So
That's what A, B, C, D are. So A plus B plus C, D is 360, right? And therefore, yeah, so from here we can just complete, right? So 2 times 360, therefore the balance 2 times 360 should be 720. Yeah, all of you good? Anyone whoever got 800, what is the mistake? Who was that? 800? What is the mistake?
For me.
Yeah, what is the mistake, Akshar? Were you able to find your mistake?
So I
Or...
don't understand.
No, were you able to find your mistake after that?
Yeah, I was.
What was the mistake? Do you mind sharing? So others also don't commit the same.
So I did it too fast. Like I thought that every small angle was 100 degree because it looked like obtuse. That's why.
Okay. All right. Okay. Now, before we discuss question 5, I want to just spend a little bit of time on reminder or modulo arithmetic. By modulo arithmetic, what I mean is when you divide big numbers, what is the remainder? So, for example, let's start with some simple example. Suppose I want 2 power, let's say 10. Okay, which is not a big number, but we can manually verify this, which is why I'm taking a simple. What is 2 power 10, Prashant?
32 squared.
Yeah, powers of 2 till 2 power 10, you guys should all know. Yes, it is 32 square. It's 1024. These are big milestones.
Yes, sir, 1024.
Oh, right,
Right?
1024.
Powers of 2, powers of 3 till 1000. You should know all of this. Perfect squares.
Yes,
right?
sir, I know.
Okay, all right. Let's do a simple quiz. All right, I could ask it in 2 ways. What does the number 784 mean to you, Arjun?
So 28 square.
Very good. 784 is 28 square. Vishwita, you ready? What is 17 square, Vishwita?
$289.
Correct, but you should be faster. Sukrit, what does the number 343 mean to you?
Sir, 7 cube.
7 cube. Nitya, what does the number 243 mean to you?
3 to the power 5.
Correct. Vanya, what does the number 729 mean to you?
3 to the power of 6.
Okay. Does it mean anything else to you, Purav? Does 729 mean anything else to you?
9 cube.
It's also
9 cube.
9 cube. Yes. Yeah. Sorry, Nitya, you were saying something?
Square.
I didn't hear you, Nitya.
27 square.
Oh, also, yeah, correct. Wonderful. Yes, it's also 27 square. Yeah, correct. Exactly. All right. And then, Nitya, can you tell me a number ABC, right? Which CBA is also, both of them should be perfect squares. Some 3 digits. ABC meaning not the product. Oh, guys, by the way, you know, right? If you put a line on top, it means the digit. You're taking the 3-digit number ABC. So both ABC and CBA should be perfect squares. Can you give me some example like this?
Statically use 400 and 004.
Okay, that is cheeky. Yes, I could say that's right. But if you avoid zeros at the bottom, so that way this is also working. This also works. Suppose a number cannot start in 0. Any other examples?
So can A and C be the same?
They can be same. Yeah.
So 121 and 120.
Very good. 121. Okay. Any other cases where A and C can be same? I think that's the only one,
The
right?
343.
343 is not a perfect
Yeah,
square.
the cube. Okay.
It's a cube. Okay. Now, if A and C are
But
different,
you have 484.
sorry, 484. Exactly.
So
484 also.
okay, is the answer 441 and 140?
Yeah, that's correct. 441 and 144. 144 and 441. Okay.
It can also be 625 and 256, right? No, it can't. Sorry.
Okay. There's also
One,
one.
I think.
Go ahead,
But
Precious.
sir, 13 squared and 31 squared, 169 and 61.
Excellent.
So I think 256 and 625 can be perfect squares.
Just one second on that one. So 169 and 961 is good, what Precious said. It's also good that there's one more jumbling that we can do and arrive at a perfect square. So it's
Wait,
not only the reverse, right? 169, 961, which answers the question I asked, but it also can be
256,
jumbled.
625.
Sir,
Yeah.
and the other interesting part is that 13 and 31 are also reversed to future.
256 and 625. But that's jumbling, right? It's not exact reverse, but yes. If I'm answering the
So the
question
other
of,
interesting part in 169 and 961 is that 13 and 31 are also reversed.
exactly, yes, correct. I remember that now. Yeah, thanks. Yeah, so what he's saying is this is 13 square and this is 31 square. Okay. Okay, fantastic, guys.
So 250 also.
Sorry, say that again, Manya.
So 250 and 25.
250.
Yes.
250 is not a perfect square, no?
So 2500. 2500.
And I'm talking, first of all, three-digit numbers and some jumbling of them, right?
Okay.
Three-digit numbers. Okay. Okay. All right. What else did I want to just cover? What digits can a perfect square not end in? Not end in.
So 7 and 8. That's 2.
237.
2, 3, 7, and 8.
And 3.
2, 3, 7, and 8. A perfect square cannot end. What digits can a perfect cube not end in?
Is that a question? How did we get 2, 3, 7, 8?
These are the four digits in which a square cannot end in.
Okay.
Just by looking at the last digits of first 10 squares, you can just see it and observe it and just tell. That's it. Okay. What are the digits a cube cannot end in?
2.
What is 8 cube?
Oh, yeah, 7.
What is 8 cube, by the way?
512.
512. Yes. A cube can end in all digits from 0 to
Sir, all of
9.
them are working, sir. I checked.
Exactly. All of them work. Okay. All right. So that's enough of. Okay. All right. Now, one last question. Is 899 prime or composite?
So prime.
Okay. Why do you say it's prime?
900 is composite. I thought 899.
Okay. 900 is composite. Therefore, 899 is prime. Wonderful. Okay. I'm not kidding. That's a good way to think about it. But what do you mean by that? A number before a composite number has to be prime.
No, sir.
Not exactly.
Sir, it's divisible by 29 and 31.
Exactly.
Yes,
How
that was 6. Not
did
a
you
prime.
figure that out, Sukrit?
Sir, because in my math exam I had this and I just remembered it.
Exactly. In fact, Arjun, you should have said it's 1 less than 900 and therefore it is composite because it's 900 minus 1. It's 30 square minus 1 square, which is 30 plus 1 into 30 minus 1.
Yes, sir. Sir, for a very, very long time, I never used to think of it this way. I always used to think, okay, 5 squared. Then what? Then 6. So then you go 1 up, 1 down, 6 into 4, 24. So
Yes.
yeah, I always used to think of it like that. I never
Today
thought
also
of
we
it like,
discussed this 13 times 17. I always look for some middle number which you can square and then you can subtract off 15 square minus 2 square, right? When I was asking this 13 times 7. Yeah, so in this case, of course, you don't need to do so much as she described 17 times 10 plus 17 times 3 is good enough. But I can take it one notch up and just say 93 times 97 would be a good example, right? So this is clearly 95 square minus 2 square. And 95 square, we know it's easy, right? It's 9025. So 9025 minus 4 is 9021. So So 93 times 97 in just a jiffy. 9021. Make sense? Okay. What is the other question I just wanted to ask? Yeah, okay. Is 2021 prime or composite?
Sir, it's composite.
Okay. Go ahead. Can complete it, Arjun?
Sir, it's divisible by 43 and 47.
Exactly. And that's because it's 2025, which is a perfect square, minus 4. And this is 45 square, right? 45 square minus 2 square. Therefore, it's 43 into 47. Okay,
Yes.
which will be very difficult to find if you go methodically, right? Because how do you test something is prime? You go one by one, all the prime numbers, you'll check divisible by 2, no. Divisible by 3, no. Divisible by 5, no. 7, no. 11, no. Then you'll slowly start getting frustrated. Till 17, you'll check. Till 19, you'll check. Till 23, you will check and then say, okay, fine, I give up. Very likely it's prime. But no, you have to go till the square root of 2021. If we didn't know that this is 45 square and all that, you know approximately that this is somewhere close to 45, right? That much you know. So you have to literally test out all the prime numbers. Till here, you'll not find success. You'll not find success. You'll not find success. You can be tempted to say, now it's prime. But the next one that you test, it'll be divisible. And therefore, it's composite. Yes, Nitya?
It was a number like 2023. What then?
Then you cannot do much. Again, look for perfect squares around it. And yes, 2025 minus 2, it's not a plus b times a minus b, for which you have to do the test. I'm not saying not always it'll work in your favor, but it's a very good first test. Like 899, it worked, right? A good perfect square, which just right around the corner, just slightly above it. For 2023, you have to literally go one by one. All of these numbers that I just said. By the way, is 2023 prime? Given this year is 2023, there'll be a question on 2023. Is it prime or composite, Nitya? It's divisible by 7. Oh, good that you brought it up, because every AMC there'll be a question that year in place. So it's 7 into 289 you recall. So 7 2s are 14. Let's do it quickly.
Sir,
7 8s are
2023 is not prime, sir.
63. So 7 into 17 square. Right? 2023 is not prime. It's 7 into 17 square. Okay. All right. How many factors does 2023 have?
Does 20 what have?
So
This number 2023 has how many factors?
So 6.
6, right? Because it's 1 plus 1 times 2 plus 1. So it's 2 into 3, 6 factors.
So what? How did you do this?
Add 1 to the powers and then multiply. Arsh, we went over this, right?
Yes, sir, yes.
If I have a number 2 power a times 3 power b and all
Yes,
that.
sir. So the whole bag.
But 2023 is 17 squared. Oh, sir, my bad. I thought
7
it was
power 1 into 17 square. Yeah.
Yeah. I thought it was 17 power 1.
Oh, okay. All right. Well, there was some other question also in between. No? Okay. All right. So for 2023, you'll keep testing. And then at 7, you'll be lucky. You'll find that it's divisible by 289. Divisible by 7. And once you see 289, it's 17 square. Okay. All right. Let's see one more question I will ask on this prime number. Okay. Okay. Which is the number? A number n is less than or equal to 100. Positive number. Okay. Integer. Okay. Which n has maximum number of factors? Which is the number less than 100, less than or equal to 100, which has maximum number of factors? Can you guys work it out? I mean, there's no methodical way, but you can sort of easily figure out. Thoda bahut. I'll give you guys 2 minutes to work on this. Which number has maximum number of factors and how many factors?
So 96.
Okay, 96. Okay, all right. 96 has 96 is what? 16. 32 into 3, right? It's 32 into 3. Okay. Okay. In fact,
Sir, I'm
I'll
getting
open it up for
60.
anyone. Okay. So this has how many factors? 6 into 2, which has 12 factors. Okay. What is your answer? 16. You
60.
said?
Six,
Which is
60, 60, 60, 60.
60. What is 60? Prime factorization?
Sir, 22 times 3 times, let me check, 22 times 3 times 5.
20 times 3 times 5? 2
No,
square.
22 times 3 times. Let me check 1 minute.
Sir, I
What do you
also
mean
got
22? 2 square.
72.
Okay. All right.
Sir, even 72.
All right. So yes, I heard you. So 72, but let's complete 60. You mean 2 square. You don't mean 22.
Yes,
Akshay.
2 squares, sir. I
Okay.
can't understand.
So
the
it has
answer.
how many factors? 3 into 2 into 2, which has 12 factors, right? So this has 12 factors. This also has 12 factors, right? Let's do 72. 72 Sukrit is, what is the prime factorization of 72? It's 8 into 9, which is 2 cubed into 3 square. And this also has 4 into 3, 12 factors, right?
Sir, even 84.
84, the prime factorization of that would be how much?
2 square times 3 times 7.
2 square times 3. Okay. That also has how many?
So 12,
3
12.
into 12, 12 factors. Yeah. So all of these numbers are 12 factors only. Yeah, I think, yeah, I don't think you can exceed 12. Let me just think about it. 3 cubed. Yeah. See, 12 factors. Oh, yeah, correct. Yeah, no. It was wrong. Yeah. I think all of these numbers have 12 factors. I don't think you can have any number that exceeds 12 factors. Yeah. Okay. Fine. Sorry. One last question on numbers. How many numbers from 1 to 100 have sorry guys, 5 factors? How many numbers from 1 to 100 have exactly 5 factors? Exactly 5 factors.
So like, is there an easier method for this, or should we like find the prime factorization of each?
Yeah. So easier method. You should be able to.
It would be numbers that are less than 100 and are to the power 4 of another number, of a prime number. Sorry,
say that again.
Numbers that are less than 100 and are to the power 4 of a prime number.
Excellent. And how many such numbers exist?
There's 2. Sorry, I mean there's 1 number.
Which is that number?
2 to the power 4.
There's also 3 to the power 4, right? 81. But yes, the first observation, that was the key
16.
observation. Sorry?
And 16.
Yeah, that's what she said, 16 and 81. But the main observation is it has to be a p power 4 where p is prime. Okay, so Arsh, why is this? Because if I have 2 power, first of all, we recognize it's a perfect square, right? Because if it has odd factors, it's a perfect square. That's for sure, right? It's a perfect square, right? So let's say it's 2 power a times 3 power. Okay, in fact, since it's a perfect square, it's something like 2 power 2a times 3 power 2b times 5 power 2c and so on. Potentially, it can be a bigger number, right? I can make the same problem instead of 1 to 100. I can make it 1 to 1000. Okay, let's do this problem 1 to 1000. By the same logic, it's a perfect square. We know it's a perfect square because it has odd number of factors, right? And the number of factors of this number would be 2a plus 1 times 2b plus 1 times 2c plus 1 and so on, right? But this number has to be 5. But 5 itself is prime. How can it be product of several numbers unless one of them is 5 and the rest of them have to be 1, 1, 1, 1, 1? Does this make sense? I'll repeat again. The number of first observation, because it has odd number of factors, we say it has to be a perfect square. If it's a perfect square, then it's all the powers are even powers, meaning the number n that I'm seeking is 2 power 2a times 3 power 2b times 5 power 2c times 7 power 2d and so on, right? And for such a number, the number of factors would be 2a plus 1 times 2b plus 1 times 2c plus 1 and so on. But I'm saying the number of factors is 5. How can product of several numbers be 5? If 5 itself is prime, the only one possibility is one of them is 5, all the others have to be 1. What do you mean by saying all the others are 1? Maybe all the others B, C, and all are 0, 0, 0, which is why you get plus 1, plus 1, plus 1. Therefore, it's all 1, 1, 1. One of them alone is 5, meaning one of the, let's for example, A could be 2, right? In this case, this is, and B is 0, C is 0, and so on, right? So that's what she said. Or A could be 0, B could be 2, C could be 0, and D could be 0, and so on, right? So in other words, if it's A is 2, that means the number is 2 power 2a, which is 2 power 4. Or if B is 2 and the rest are 0, it is 3 power 4, or 5 power 4, or 7 power 4, and so on. But within 100, there are only 2 of them because it's 2 power 4 and 3 power 4. And suppose I change the question to within 1000, I can look for more, right? 7 power 4, has it exceeded 1000? 49 into 49, right? It's exceeded 1000 already. So with 7 power, with 1000, you'll only go till 5 power 4. Does it make sense? Yeah. And suppose it's 10,000, then also it's not very difficult, right? So, right. So what is the approximately till 10? You have to go 10 power 4 is 10,000. So we'll go till 7 power 4. That's it. So even though we increase the number till 10,000, there are only 4 numbers less than 10,000 which have exactly 5 factors. Is this clear to everyone? Okay, all of you clear? Thinking, should I give another one? Okay, all right, let's do this one. How many numbers? Let's keep it simple. 1 to 100 itself. 1 to 100 have exactly 6 factors. Okay, how many numbers from 1 to 100 have exactly 6 factors? Okay, we'll wrap in another 5 minutes. Okay, so if people can, whoever has another class, please drop off. It's fine. If people can stay, then another 5 minutes, we'll discuss this and wrap.
Sir, I have to go.
Okay, fine, no problem.
Thank you, sir.
Bye.
I can say this much, that it has n to the power 2 into y to the power 3, such that n and y are both prime numbers. I just need to
A small mistake in what you're saying.
It will be n to the power 2 into y to the power 1.
Ha, exactly. Yeah. Yeah. Let's say P. So P power, let's say P and Q are the prime numbers. P power 1 and Q power 2. So that when you add 1, it becomes 2 times 3. Right, Nitya? Not 2 and 3, but 1 and 2.
Sorry.
Okay. Yeah, that's fine. Or any other options?
So can you repeat what
Something
you
cube.
said?
2 to the power 5, 32.
Oh, cube of a number. Oh,
Not cube of a number, but the 5th power of the number. Yes. Not cube, but yes.
32.
Correct. Yeah, I'm just saying in a general format, it's P power 5. Yeah. Okay. Arsh, the question was how many numbers have 6 factors? By the same logic, so let's say it's 2 power A times 3 power B times 5 power C and so on. We know it's not a perfect square, but we need the product of A plus 1 times B plus 1 times C plus 1 and so on. That should be 6.
Yes.
How can you generate 6? You can generate 6 as either 6 times 1, 1, 1, 1, 1, or it can be 3 times 2 and 1 rest have to be 1, 1, 1. So 3, 2 combination, if you leave out all the ones, because 1 is what we get by default, but not having a prime number, it's 1. So either a 3, 2 combination, or just a 6. So 6 means what? 6 means a prime
5.
number to the raised 5th power.
5.
And 3 times 2 means what? It's P
2
power
is 1. 2 and 1.
Exactly.
2 and 1. Yeah.
Yeah. And now it's easy to figure out. So P power 5, how many powers of 5th powers we have within 100? Only one of them. 2 power 5 is the only one. Right?
Oh, yes.
That's,
Sir.
3 power 5 is exceeded 100 anyway. And then now we can figure out in this p square q combination. So let's start with p equal to 2. Okay, so if p equal to 2, so it can be 2 square times 3, or it can be 2 square times 5. We keep going till we exceed 100. So 2 square is 4, remember? So until this number reaches 23, I'm fine. So 2 square times 7, 2 square times 11, 2 square times 13, 2 square times 17, 2 square times 19, 2 square times 23. Till here, I'm fine, right? Now I'll go to the 3 wala series. So 3 square times what? 3 square times 2. 3 square is 9. So I can go till 9 times 11, right? So 3 square times 5. They have to be 2 distinct primes. Huh? I cannot say 3 square into 3. 3 square times 7. And then 3 square times 11. Just about reached 100, right? 99. Okay, the 3 series is also complete. Now the 5 series. 5 square times 2. 5 square times 3. And that's it, right? Now I can go for the 7 7 square times 2. And that's it, right? Now I'll go for the 11 square times 3. 11 square itself is exceeded 100. So not possible. So all of these numbers, which we can count by hand, have exactly 6 factors. Is this clear to everyone? Yeah. Okay, cool. Let's end the class and we'll begin the next class by discussing that question 5, which is an important one. And then homework 4, of course. Okay, see you guys. Bye.
Bye, sir.